Good afternoon, everybody. I hope you can hear me. I will pretend this arena is not in the least intimidating. And also, I might have a lot more material today than I can fit in 40 minutes, so I'll be possibly skipping over pieces of my talk. Yet, I will try to take questions during the talk. I'll make some breaks for your questions. If my colleagues in the audience will be able to reach you with microphones, this will work out. If not, we'll take all the questions at the end. Okay, so welcome to the Shoulders of Giants talk. This is a presentation about the languages that we learned from when we were working on Kotlin's design. And I need to start with an important disclaimer. So, I used to work on Kotlin for 10 years. I led the design team, led the entire project team, and worked on the big part of the slow compiler everybody's suffering from. And today, I'm not affiliated with JetBrains or Kotlin. I moved on to something else. And nothing I say here is official. You can safely assume everything I tell you is a lie. Okay, so let's start with how do you invent a new language? It seems to me that many people have this interesting notion that things get invented from scratch. In fact, almost nothing in the world gets invented from scratch, and you always build on top of some existing ideas. So when we started working on Kotlin, we looked at all the languages we could reach, and we kept our use case in mind, our users, what they need. We looked at what would suit them from different languages, and then the big challenge was how do we put together all those different pieces that work nicely in here and there, but nobody ever thought of putting them together. So how do we make that work? How do we patch up whatever common pitfalls there were in those languages? Because some things, you come up with a new idea, you roll it out, it's mostly great, but some people are complaining about something and you can't take it back. In languages, if you release something, it's really hard to fix the design after the fact. So when you're learning from someone, you can fix their design before rolling it out in your language. And of course, if something is not covered with existing ideas, you can invent something, but it was not the point of Kotlin design. And I came up with the idea of this talk because people seem to fight so much on the internet about who invented what. And I wanted to help them out a little bit by just telling you who actually invented what ideas, so which things came from which languages, and try to settle the debate once and for all. So we'll talk about particular examples, many of them, but the big idea behind this talk is that when you pick a language to program in, it's rarely for originality. If you like Kotlin, it's probably not because it's not like any other language. It's largely because it is like many other languages. And it puts those ideas together. And building on other people's ideas is a good thing. If you build something, build on other people's ideas. If you like my idea, take it, please. And altogether, today we'll be giving credit to people I'm grateful for all those nice ideas. So the motto for Kotlin from very early days was to be a pragmatic language for industry. Pragmatic means we're not trying to be super mathematically beautiful. Elegance is secondary. Many things in Kotlin are ugly on the inside. Like we would take some very nice, beautiful mathematical idea from the academic world, and we adapt it to our environment with Java interop and usability and IDE and all that, and it becomes not so mathematical. And industry is an important thing there too, because we made a language for large projects, worked on by large teams for a long time. So many things actually come from these constraints. So let's start with what languages did Kotlin learn from actually? What do you think? Just shout the names. Scala, okay. Swift. Java. C#, that was another name, I couldn't hear it. Dart, okay. Closure?
Golang.
Groovy, and I couldn't hear the other voice.
Golang.
Golang, okay. Okay, some of you will be surprised, but what do you think, what is the language Kotlin learned from the most? Scala, not Scala in my opinion. Java, of course. But Scala did have a lot of influence. So let's play a game. This, many people fighting on the internet say things like, Kotlin is just, and then, what language is this? I'm sorry. Sorry, I didn't mean not on my slide, sorry. Yeah, so what language is this? There, Kotlin. Any other?
Scala.
It's Kotlin or Scala. This will compile in Kotlin or Scala. So many people say that Kotlin is just Scala without all the nice things. Nice things being in different people's minds, like implicits or view bounds or higher kinds or whatever. So one could say probably that Kotlin is just Scala without all this stuff. But there are other points of view. What language is this? This is Kotlin or Java, or a good point, JavaScript. So some things actually were inherited from Java, or C actually. Yeah, well, with a dot, not C, but C++, yeah, it could be as well. So, yeah, possibly Kotlin is Java without all the, I don't know, ceremony. And this one, what language is this?
Kotlin, JavaScript. Groovy.
Groovy. Groovy is a good point. Or Kotlin. So, Kotlin may be groovy without all the mess, I don't know. And this? C#, correct. So, can be C# without all the Microsoft? I don't know. So in any case, Kotlin was influenced by many languages, and these are like the biggest influences. Java and Scala are very big there. Groovy and C# influenced a lot. Python quite a bit, and many others. Tiny influences from Go and other places. I will name them as I go, but what I'll try to illustrate today is that the whole thing is about taking things from different languages and putting them together, because it's not easy to make something from Java and from Python make work together. An important slide that's hard to read. This is the timeline. So we started Kotlin in 2010. At the time, Java was version 6, and we worked till Java 8 with 1.0. And Scala was version 2, Groovy was 1.7 through 2.4. Swift, notably, was not known. It was already being worked on, but it was secret. We couldn't look at it. I would love to have been able to look at Swift, but I couldn't. So it was only to the very beginning, to the very end of our development cycle, we could look at Swift. And C# was 4, 5, and 6. Python, Python versions are complicated, but 3 was already around. So keeping that in mind, this is the context of how we worked on it. Let's begin with scratching the surface. Actually, this is something most people see first when they look at the programming language. It's syntax. Syntax is something that everybody more or less understands, so everybody has an opinion about. That's a big problem in discussing languages, because there are huge arguments about which side of the name should a type go on. In any case, I'm sorry. In any case, there is quite a bit of influence from Scala in this regard. We have no semicolons, and semicolons were there in C and Java for a reason. They help you break the lines. But actually you have this nice key on the keyboard called enter or return, right? It breaks lines for you. Problem is, you sometimes want to break lines with return, whether they don't break for a programming language. So you want to break this assignment expression into 2 lines, or this into 2 lines. And if you want to get rid of semicolons because they're noise and an extra keystroke and so on and so forth, you have to make compromises. And Scala had a very nice set of compromises. Other languages also had them, but differently. Like in JavaScript, there are issues with these. And Martin Dursky figured it out very nicely. And the biggest compromise is this one. So if you break a line before a plus, this is 2 statements already. So you assign A to A, new line is your semicolon, and this is just a plus B on its own line. It's an expression, plus B. Makes not so much sense, but it's a separate expression. So if you want to break a line like this, you go with parentheses because the parser is smart enough not to put semicolons in the middle of the parenthesized expression. That's one important influence from Scala, and it's very nice. I'm very happy we learned this. Another thing is val and var. The whole design space around this is pretty complicated because probably the first question we ever got about Kotlin in the early days was why the hell would you have types on the right? Who on earth does it differently from all the great languages, C and C++ and C# and Java? And I'm like, okay, I can name a few languages, but this is definitely not the point of this conversation. And actually, so we were kind of nervous if this was a good idea. We saw that it was technically working pretty well for Scala. So there was some confidence there. So we kept explaining that it's much nicer this way in terms of type inference. It's easy to omit a type from the right, because if you omit it from the left, you have to put something there. And this is what C# and Java do, right? They say var in front and add noise instead of omitting a type, which is kind of not ideal. So we wanted to go the Scala way here, and we wanted all our prefixes to be aligned nicely. And also, many of people on the team speak Russian, and Russians love 3-letter words. So all this is okay, but the problem is Scala and, say, Python have def in the place of fun, and def is an interesting word. It means definition, which these things are very frequently not. They're declarations. So we were like, okay, what do we say for a function? Some people, JavaScript, name it function, which is kind of not what we wanted. Some say fn, some say func. And also, we're not native speakers of English, so we were not sure if saying fun here would be not out of place. Because, in Kotlin, you can say fun, you can say have private fun, or public fun, or you can expect fun, or you can have public actual fun. And we were kind of on the fence whether this was okay or not. But fortunately, in the ML family of languages, which fortunately come from England itself, Robin Milner called functions fun, and nobody had any problem with that. So we went with this. And so all the jokes are going around. So Scala and ML are biggest influences here. Also, I once was talking with Martin Dursky, the creator of Scala, about whether he thinks Scala is a functional language. Because it's complicated. Like a purely functional language like Haskell or ML is a very obvious thing. Like everything is a function, you have read-only data, all that. But Scala is not quite like that, right? You have a lot of mutable data, you have classes, all this. So I was saying, Martin, why do you think Scala is a functional language? And he's like, oh, that's very easy. Everything is an expression in Scala. It means it's a functional language. And it's a viable definition. So in this sense, Kotlin is a functional language. Everything's an expression. If it's an expression, when, which is our version of match, is an expression. Even try catch is an expression. Who knew that it is? Okay, some people learn something new. Even return is an expression. I have a history of emailing the creator of C#, Anders Hallsberg, asking him why throw was not an expression in C#. And his answer was like, it's a tradition, more or less, we didn't care. And it turns out if you do care, you get nice things like this. So we inherited all this from Scala and are very happy about it. A few things are not expressions, loops, most notably, but this is, this is something that you can't give any meaning to. Another thing that's coming from also mostly Anders Hallsberg, who worked on Turbo Pascal and Delphi and C# and TypeScript, it's soft keywords. You see, in Kotlin you can say data class data, or infix fun infix, or const val const. And this is something you can't do in most languages. Like in Java or Scala, for example, you can't call your variable private, because private is a keyword. Or you can't call it const, because const is a keyword, and so on and so forth. In Kotlin fun, for example, is a proper keyword. This is a hard keyword, because you can't make, wow, are we taking off? Yeah, sorry. Because you can't make the parser understand all the syntax without a few hard keywords. But many things are actually soft, and we have twice as many soft keywords as hard keywords. So this is like advanced 21st century parser technology, and thanks to Anders Hallsberg for this. Also, language design is not only about taking things, but also leaving things out. And there are many things we didn't take from many languages we learned from. And specifically Java, no weird C-style for loops. I have no idea how Dennis Ritchie came up with this, but it's weird. No ternary operator. I'm sorry. We should have had it actually. No assignment expressions. You can't assign inside a condition. No bit shift and other bitwise operators. And this has actually pretty deep roots because there are no angled brackets in the world. So this is a greater sign and an angled bracket. And when it's sometimes a part of this, it just makes things so much more complicated. Not that we couldn't do it, but it was just too much work for too little gain. And from Scala, we didn't take many things. Like this thing, where this becomes a lambda just because I put an underscore there. This scared me so much when I was learning Scala, and I have a history of debugging one line of Scala for 40 minutes before I could figure out all the implicitness going on behind the scenes. So this scared me so much that in Kotlin we have curly braces around every lambda. You always see a lambda through curly braces. Also, we left out all the ASCII. Sorry, you can do this. Or this. No. Also, I'll tell you about arrays a little later. And another example, what language has influenced this? Specifically here. Okay, so it's actually coming from Python. Because it's a new object instantiation. We're creating a new instance, and Java or Scala or C# or Groovy would have a new keyword in here. And at some point we just looked at the Kotlin's grammar and figured just this new keyword wasn't really needed. We didn't need it for technical purposes. Java and Scala do need it for technical purposes, we didn't. And we were like on the fence, is it important to mark every object creation in the program with a keyword? Looked at Python and decided no. And it worked pretty well. Nobody is missing the new keyword, but there is a technical consequence. So you have to make these different ideas work together. And without a new keyword, we'll lose the standard Java and Scala syntax for creating an anonymous inner class. So you say new superclass name in Java, we can't say it in Kotlin because new is not a keyword anymore. So we had to invent some other syntax and say object something instead of that. So this is an artifact of putting together a piece of Python with a piece of Java, Scala, C# or something like that. Okay, let's try and take 2 questions. If anybody has questions, put your hands up. Okay, let's see if I can hear you over this.
Yeah, regarding the last thing you showed, isn't it possible to just leave out the object here?
Oh, totally, great question. Yeah, let's say I drop the object keyword in the column, then I have a function named base being called with no arguments here and a lambda here, and I'm screwed. More questions?
Another question?
Okay, I'll take another question in the next break. Thank you. Okay, now let's talk a little bit about the basic abstractions we have in Kotlin. Top-level functions, free functions. The idea is coming from all over the place. It was actually Java's big leaving out free functions because they existed in C++ and C, of course, and many languages are putting them back, like all the Groovy languages have them, Scala has them, so on and so forth. So we had top-level functions and top-level properties, and since we are interrupting with Java, so we have to expose nice APIs back to Java, we have to do something like this. Like for a file, we have some sort of class name, which these actually go into as Java methods. And now here is an interesting thing going here. And so we have in Kotlin a type named unit. And unit is sort of a weird word. It's unit, it's as in unit of measurement, right? It's one of something. Why would a function that doesn't return anything return a unit? Well, it's actually an interesting story because this thing, we just couldn't come up with a better one, so we copied it from Scala. And Scala has it from its academic background. The unit is actually a tuple of 0 elements. It's a very algebraic thing, and that's why it's a 1. But more importantly, why don't we have void here, or nothing, because this function doesn't return anything, right? Actually, a function like this does return. It just doesn't return anything interesting. And we couldn't say here, nothing interesting, because it's too long. And so the problem is that back in the day of C, Dennis Ritchie decided that his function that doesn't return anything interesting will say void for a lack of type, like there is no type. And in our case, it means that we can't extract the type from this function. Like we can't, wow. Somebody up there is not happy. So basically, if I want to turn this into a function type, function value, I can't say it doesn't return any type, right? It returns something. And so the name void in English means nothing. And nothing signifies something completely different. So we couldn't take void. And nothing is a name, proper type name in Kotlin. So we had to go with something here, and it took Scala's decision for unit. And by the way, here is what nothing type looks like. It's a function that doesn't actually return. It throws. And there you have a proper empty type. Like not nothing interesting, but nothing at all is returned. Next interesting thing about functions will be extensions. So this idea sort of floated around in different languages, especially, of course, dynamic languages have very easy extension mechanism because they can patch objects at runtime. but static languages do, and C# was obviously the pioneer of this in the large mainstream space, but Scala also had a solution. And Scala, you used its implicit classes at the time. Now it's sort of changed. But at the time it was implicit classes, so you injected an instance around what you were extending every time you were calling a function. In C#, you had to create a class and put a special static kind of method with this here to make it work. So we wanted the idea, we didn't like the implementation in Scala or C#, we came up with something else. And the big question here would be, why do we have extensions at all? And there are many things we like them for, right? You can actually add a missing method to the library. You don't have to like send a patch to OpenJDK to add something on a string. And this kind of gets you rid of string util class. Who doesn't have a string util class in their Java project? These are very small projects, I bet. Yeah, so this whole thing with the util classes goes away, and code completion in the IDE can be nicer because you know how to propose things after you're done, so on and so forth. But these are not the actual reason why you should have extensions in your language. The actual reason is to keep APIs minimal. You don't have to put all the nice utility functions into your main type. The string type in Kotlin, for example, is really, really small. It has only two methods, length and character at position. That's it. Not hundreds of methods like in Scala or in Java. Because we can have all the extensions and the core API can be kept minimal. And this goes for any library design that you're doing. So this is why it was important. And you probably know the syntax that we came up with. So we put the type in front of the name just to match the call sign. But again, the person here is just two names, and that's it. All the other stuff is outside this API. It's just utility extension functions that look as nice in the code, but don't pollute the interface. Any questions at this point? There is a hand up there. Okay, it will be a race. Okay. I'm sorry.
I would like to ask about a very good idea that was a property delegation, and a very bad one that was an interface delegation. So where does it come from?
Okay, I hopefully will get to it at the end of my talk. So sorry for not taking this. There was another hand right here somewhere. Okay. Can you just pass it? Yeah. Go ahead.
I have a question regarding the extension method. Who decide what API is clean? So
You as the API designer. But the thing is, you can minimize it. The smaller you keep it, the easier it is to combine it with other things.
is there a risk to this decision? That's
Always. Yeah. When you design something, there's always a risk that you make a mistake. Yeah. Sorry, man. All right. Thank you. Let's talk about higher order functions. And does anybody recognize this syntax? Okay. Thank you, old timers. So this is how we started the higher function design, function type design. So this is a map function that takes a function as an argument. And this is the initial syntax that we had. We wanted it to be like similar to the declaration of a function. But can you actually tell if I closed all the parentheses here correctly? I usually can't. That's why we changed it to what you know now. And also, this A here, where is it declared? Who defined the name A? The answer is here, which is weird because it's to the right. So all this was the initial design and it changed to this. So all the declarations in front of usages and the arrow syntax for function types. It's influenced by Scala, of course, and Java. But also, there is this interesting thing, and thanks a lot to Groovy for this, because without Groovy, what we would have would be something like this: a lambda in parentheses, and a stupid name nobody cares about every time you use a lambda. So what Groovy has is you can pass a lambda without parentheses if it's the last argument, and you can say it by default. It's not a keyword, by the way. It's just a default thing the variable gets. And this way you can have nice syntax like block-like, language-like constructions in your DSLs very easily, thanks to Groovy. And of course, you can also have things like this, where you can construct hierarchical declarative things with those DSLs, but the big difference from Groovy is that here you do it in a type-safe way. So in Groovy, the builders initially were a dynamic feature with like all the dynamic power of Groovy used to implement this. We had to figure out a way to make it static. And this is again how you take a great idea from another language and make it work with all your static stuff. And by the way, why static? Kotlin has a static type system because it is a language for industry. It's for large scale, for big projects where you need refactorings to be precise on your whole code base, and I'm sorry for all the bugs in the IDE. So the continuation of the Groovy story would be something like this. Like, okay, we can make all those nice blocks, but can we get rid of some noise through a library function like with? And this idea sort of comes from Pascal. Who programmed in Pascal? Oh, it's actually many people. Cool. Yeah, so Pascal had this as a language syntax construct, and we have it as a function. And the way it works is you put all you already had together, like functions, higher order functions, lambdas, but you add extensions where they were missing. So we had lambdas, we had to add extension lambdas on top to make this whole thing work, so that the implicit this in here can be just omitted, and we get that. So this is again an example of putting many existing language features together, adding a small thing to make it all click into a new big use case. Okay, what language is this?
Basic.
Basic? Any other options? It's Scala. It is actually an example from the Scala documentation. And this is to illustrate the power of Scala DSLs that we didn't want. We figured, okay, doing basic in Scala is cool, but we probably don't want to go that way. So we limited Kotlin's DSL abilities quite a bit to just a few things with proper word names, not characters. And also we do everything by convention in Kotlin, which is actually an influence from C#, where you don't have to implement an interface to make iteration work. So you can provide extensions and your iteration will work by convention, not by interface. And we made sure everywhere in Kotlin we could do this. Delegation properties, all other stuff, work by convention, because it's much more flexible than by interface. It's sort of non-intrusive, a little Go-like, but it actually comes from C#. Okay, I'll try to fit generics in because it's interesting. So, Kotlin has generics, and it couldn't live without generics because Java already had them and we needed interrupt, so generics are mandatory. There are different ways of doing generics in different languages, and Java generics are limited in many ways. They are erased, so you don't have access to most of them at runtime. They come with weird things that are like raw types, so on and so forth, and there are many other interesting things I will illustrate later. So C#, for example, had them the nice way. They are reified, and all the runtime unavailability is solved there. C++ obviously had a very powerful thing that you can meta program in all your life, but it's like too scary. And the initial design for Java generics came actually from Martin Nadersky of Scala fame. His first language was called Pizza. It was a prototype of how you add generics to Java in a compatible way. And unfortunately, they turned down his proposal. It was a big mistake. I'll show you why. So we had to right this wrong a little bit and take Martin's proposal. And you didn't got it. So, but first, let's have a look at this. So Java has generics, the syntax of generics in a little weird way. You say array list of foo, which is fine, but then you say collection.foo empty list. Why would you do that? And I would like to point out that it was very smart people came up with this syntax. They had a reason. And then in Scala, you can say no list of foo, no angle brackets, square brackets. Empty list of foo is fine on the same side, but then you have to say array of 0 with round brackets. Like a little bit not familiar. That's because we've used the square brackets here, we can't use them both here and here, because they are for types. And there is a good reason why Scala and Java have this in this sort of not ideal way. Question, how many named functions are called here? Named functions are those with character names, like a plus is not a named function. How many? 3. What are the 3? I can hear 1 and 3 and any other options? 2? Okay. So the obvious interpretation would be a function foo called a function bar of type arguments a and b and this expression. But how come it can be 1? Look here. I just changed the big letters to small letters to make it more clear. Okay, it's function foo of bar less than a, comma, b greater than x plus 1. And how should the parser know? And this is why Java has it this weird way with angles on the left, and this is why Scala uses square brackets, because this grammar is inherently ambiguous. It's mathematically impossible to solve this unless you're C# or Kotlin. You can just say, okay, we will have the best of both, and if you need to disambiguate this weird thing once in your life, we'll use brackets here, you know? So actually, this is an ambiguous grammar still. We just made the parser choose the one option over the other, just make it prefer one of the interpretations. And if you wanted the other, just use braces, that's it. So this is also how, you know, over time, you work out nicer solutions when other people had to struggle. And thanks C# for this. And the last bit on the generics story will be about variance. So I told you about Martin Nadersky's proposal. It was a good one. They turned it down and used this. It's called use-side variance. So to put something in a bag of what's supposed to be animals, you have to say something like this. Because it may be not animals, you can pass a bag of objects here and put animals into a bag of objects. And Kotlin would say it this way because we have to interop with Java, so we had to mimic this, but this syntax is super scary, so we used in. I'll be putting animals into this bag. This is Java proposal. What Scala, what Pizza was proposing was this. Declaration side variance. Say that from this class you can only return t's, or from this class you can only take t's in, and don't use this weird thing on the use side. just say your list is only reading things in, and mutable list is reading and writing. So in Kotlin we say it this way, out and in. Actually, these keywords come from C#, because they have a limited version of declarations and variants as well, only in interfaces. But we use their syntax. And so this is like, we took Martin's proposal. Java should have, but they didn't. And we had to combine the two now, because again, it's nice ideas from different languages. Well, Java forced us to have theirs. Scala was nice enough, so we had to put it together. And as far as I understand, we had to be first to figure it out. We used help from a professor from Cornell, Ross State, and we had to adjust his ideas to the real world. So it's not pretty on the inside, but it's working. So if in Java you have extends and super, in Kotlin you don't say anything here, because list is already declaration side covariant, and you can say in here to make it work. Questions? Go ahead.
Here.
I just want to go back to when you were explaining the syntax of functions. So columns can be used to define the type of a variable or to define the return type of a function, but for lambda, arrows define the return type of a function of a lambda. So why not use arrow to return the type, to define the return type of a function like Swift does?
Okay. The same reason we didn't use the fun syntax for the types, because it will be like at the end of the function declaration, it will be arrow something, bracket arrow something, and you get lost. How am I doing in time? Okay. So as I said, I have more material than I can cover. Unfortunately, I'm 1 minute over time already. Thank you very much for your questions. It was great to see you.